Okay, today we are classifying triangles. You can classify triangles two ways, either by their angles inside the triangle or by the sides. So, who knows the actual definition of a triangle? What do you think it is, Jonathan? Yeah. What do you think it is? Do you think it's a three-sided polygon? Two? What do you think it is? A triangle with three sides. 180. It always does. It always does have three sides. All right. Raise your hand if you think a triangle is a three-sided polygon. Raise your hand if you think if that's the definition of a triangle. Okay. Who's not? Raise your hand if you don't think that's the definition. If you don't think it's the definition. All right. Why do you not think it's the definition? What do you think the definition is? Say it out loud again. It's a property of a triangle. It's not the definition, though. All right. Watch this, guys. Watch this. You guys told me a three-sided shape, right? Three-sided polygon. Side 1, side 2, side 3. That's what I was looking for. A triangle is really a closed three-sided polygon. Triangles have to close. Nope, they can't be open or free. Triangle ABC can be written as the triangle symbol A, B, A to B to C. So that's the triangle. You should trace them if you get confused. Since side A, there's three sides to a triangle, three vertexes to a triangle, and three angles to a triangle. These two are kind of the same thing, though. So we have side AB, so we can start at A. We have side BC, which is right here. And we have side CA, which is right here. So those are the three sides. We also have three vertexes. Vertex A, vertex B, vertex C. Angles, we have three angles as well. Angles A, angle B, and angle C. Triangles always come in threes. Pairs of threes. It does mean three. So what does triangle mean? Three angles. Mm-hmm. All right. You can classify a triangle by its angles. An acute triangle has three acute angles. And acute angles are, so it's going to have three angles less than how many degrees? Nope. 90 degrees. An equilateral triangle has three angles that are the same. Three angles that are the same. Three angles less than 90 degrees. Without just guessing, and don't just guess, an equilateral triangle, equiangular triangle has three equal acute angles. Does anyone know how many degrees each angle has to be without just guessing? Nope. Nope. It's 60. Why is it 60? Perfect. We know there's 180 degrees in a triangle. What? Because there's 180 degrees in a triangle. If it's 3 equal angles, you can do 180 divided by 3. That is 60. So each angle in an equal angular triangle is 60 degrees. All right, now you guys have a lot of trouble pronouncing this, so just pronounce it with me. No. Everyone say equal. Everyone say angular. Combine those together. Equal angular. There you go. It's actually equal angular. Equal angular. Most people, you will probably, most people, 99% of people will be fine with you just saying equal angular. Actually, I don't think anyone would not be fine with that, so whatever. Except for Jonathan. I'm perfectly A-okay with it. An obtuse triangle has one obtuse angle in it. Here's our obtuse angle, it's right here. So one angle more than 90 degrees. And then finally, a right triangle has one angle that is exactly 90 degrees. One angle that is 90 degrees. And it's typically marked by that symbol right there. If you ever see that symbol in a triangle, it's going to be a right triangle. I don't know. Some people see it as a box. I kind of see it as I see it as a that symbol. All right. So, I want you guys to work in pairs, think, pair, share, and solve A, B, C, and D. I'm going to give you guys like 2 minutes to do that. Okay. Who knows the answer for A? All right, who said me? Daniel. Why is it an obtuse angle? You look for the largest angle. The largest angle is 110. That's more than 90. This is an obtuse triangle. Good job. Daniel, you can choose someone. Is what? Good job. The largest angle is what? 89. And then that's an acute angle, so that this is an acute triangle. You can choose someone. Brian, what type of triangle is this? Why is it a right triangle? Nope. Because of the right angle. And what type, Brianna, you can choose someone. Adrian, what type of triangle is this? Equal angular triangle. Why is it an equal angular triangle? They're all equal. But that's not why it was. Okay. All right. I'm going to give you guys about a minute to work on this one. Turn to your partner and see what you think the answer is. For just example 2. Triangle ABC. But try to classify that triangle. Everyone will answer this one. Okay, time's up. Time's up. All right, raise your hand if you think it's an acute triangle. Raise your hand if you think it's an obtuse triangle. Joanna's right.
I tried that the last one, it didn't work.
Okay. Okay. This is our triangle A, B, C. Our first angle is 32 degrees. Our second angle is 55 degrees. Our third angle is all of this, which is 58 plus 35. 58 plus 35 is 93 degrees. Is 93 more than 90? So that it's an obtuse triangle. Classification of triangles by sides. You can also classify it by how many sides are the same. So for example, an equilateral triangle, all three sides are the same. And we know that because look, there's 3 congruency ticks. 3 of the same congruency ticks. An isosceles triangle has 2 equal sides, or at least 2 equal sides. And look, it has 2 congruency ticks. And then finally, a scalene triangle has no congruent sides. And look how there's congruency ticks look. All 3 of these congruency ticks are different types. We have a 1 tick, a 2 tick, and a 3 tick, right? So all 3 of those are different. That means all 3 of these sides are also different. Okay. Let's look at example number 3. If point M is in the midpoint, so here's point M. It's in the midpoint of KL. That means it splits KL directly in half. So that means KM and ML have to be congruent, right? So if there's a tick here, there should be a tick right here. Classify JKM as either isosceles, scalene, or equilateral. So, can this be scalene if we have 2 congruency ticks? No. Well, it looks like it's an isosceles triangle. But it can also be an equilateral triangle. We need to check. We know 1.5 is being split in half. So what's half of 1.5? 7.5. Well, look at this. We have a congruency tick here, here, and here. So if this is 0.75, what does this have to be? What does this one have to be? And we are looking for triangle JKM. Are all those sides the same? Yes, they're all the same. So that is an equilateral triangle. There's one here. Points. Here? What do you mean? No, but we're looking at this triangle here. No, this one's 0.75. This is an isosceles triangle. Yeah, does not have a congruency tick. Yeah? Mm-hmm. Alright, they're going to get a little bit trickier now. We do it specifically to annoy you. No, I'm like, when I'm creating these, I'm like, oh yeah, Joanna would hate this, yeah. Let's add 2 of those. Okay. I am being recorded. Later, skater. Alright, moving on. Find the measure of the sides of an isosceles triangle DEF. DEF. Okay. DEF. Now, what 2 equations are the same in this? Well, let's look at our congruency ticks. These 2 are the same. Why do we know that? We have 2 congruency ticks, here and here. 4x plus 3 is equal to 6x minus 1. Minus 4x minus 4x. We get 3 is equal to 2x minus 1. Plus 1 plus 1. We get 4 is equal to 2x. X is equal to 2. That's not our answer. It asks us to find the measures of each side. We had to find x in order to find the measures. So we can plug in what for x in all 3 of these? 2. So we can say 4 times 2 plus 3 for this one. 4 times 2 is, plus 3 is, so this is 11 units. And by definition, how many units should this be? Also 11. Well, let's double check that. 6 times 2 minus 1, 12 minus 1 is 11. Yay, it's working out. And then how many sides, or so how many, by definition, what should be the size of this top one? Why is it not the same? Does it have 3 congruency ticks? Then you can't assume that it's the same. I was trying to trick you guys. 9 times 2 minus 5 is 18 minus 5, which is 13 units. What's your question, Joanna? Yep, because we figure out x is equal to when we plug it back in. No, it's for all the x's. I can see where you're coming from, but it's for all x's, you see. Alright, this last one. Find the measure of the sides of an equilateral triangle. Equilateral means you have 3 equal sides. So these are all equal. This is equal to this, and this is, they're all equal. So it doesn't really matter which 2 you choose to set equal to each other. There's one that's easier than the others. But you just create your equation to find x. You can choose, I don't know, these 2 would be fine. These 2 would be fine. These 2 would be fine. Any combination like that is fine because they're all equal to each other. Who knows what the easiest one is, though? Which? Okay, 2x. 5x minus 7. Oh, 2x plus 5? Oh, okay, whatever. Set those 2 equal to each other. It's not the easiest one, but okay. These two would be the easiest. You have a 5 and a 4, that's a difference of 1. You wouldn't have to divide. So now we have minus 2x minus 2x. That's 3x minus 7 is equal to 5. Plus 7 plus 7. 3x is equal to 12. X is equal to 4. Now we have to plug them back in. 4 times 4 minus 3. 16 minus 3 is 13. 13 units. If we did our math correctly, they should all be 13 units. Well, let's see. Let's see if we did our math correctly. What's 3 times 4 plus 5 is 13. 5 times 4 minus 7 is 20 minus 7, which is 13. Oh, look, they're all the same. Yeah, we're using it to double check. All right, when you miss your test, I'm like, oh, should have double checked. All right, your homework due on Monday is going to be the evens on this on the homework page, front and back. Speaking of grades, our first grade of the 6 weeks of this third 6 weeks is going to be your exit ticket, which is these 6 problems. Evens on that. Evens on the other page, by your elbow. Monday. Yeah. So you guys aren't listening to me. What's due today, though, this is going to be your first grade of the third 6 weeks, is 6 through 11. You're turning this in on Schoology, so you'll find these questions 6 through 11 on Schoology. Turn them in today. That's your exit ticket. You can use your phones to do it at Schoology.